Alright, so this is a Chapter 5 review. It's going to be two parts. The first part's going to be a little bit longer than the second. I'll just kind of jump into it. So the first three questions want me to find an antiderivative or an integral. And for the very first problem, it's written with a radical, and I don't really know how to integrate something when it's written in radical form. So I'm going to rewrite this problem with a fraction exponent. And the fraction exponent version of this problem is the integral of x to the 3/4 dx. You notice there isn't numbers on top or the bottom of the integral sign. That means when I get my answer, I have to tack on the plus c, as opposed to plugging numbers in and getting an area. So I have the problem rewritten. I'm now going to drop the integral sign because I'm going to do the integration by adding 1 to the exponent, and I'm going to divide by the new exponent. And when I add 1 to the exponent, it's probably going to be worth my time to write the 1 in fraction form. And the fraction form of 1 that I'm going to write is 4/4, because 4/4 equals 1, and it's a convenient form of 1 to add to 3/4. So my new exponent's going to be 7/4. And after I add 1 to the exponent, I'm supposed to divide by the new exponent. So I have my choice of dividing by 7/4 or multiplying by 4/7, because dividing by a fraction is the same as multiplying by its reciprocal. And instead of adding 1 to the exponent, dividing by the new exponent, I'm going to multiply by the reciprocal of the exponent. That's the integration part without the plus c, so I need to add the plus c. Now I'm going to write my answer. My final answer to this, or an acceptable form of the final answer of this, would be 4/7 x to the 7/4 plus c. Like I said, this is probably an okay answer. It's the version of the answer that I would want to use if I was trying to check to see if this is the right answer. It's probably not the best answer. Because the initial problem is written with a radical, it's probably best to write my final answer with a radical. So I'm going to call this the best answer. And to take a fraction exponent and turn it into a radical, the denominator of the fraction exponent becomes the index. The rest of the part of the fraction exponent goes under the radical. So I'd say the best answer would be 4/7 times the 4th root of x to the 7th. Of course, if you remember how to reduce this, you could even get a different looking answer that's even better. We're completely not going to worry about that. But if you instinctively wrote this, that might be the ultimate best answer. 4/7 times x times the 4th root of x, that's to the 3rd power. Any one of these three answers is going to be okay. This is, I'd probably call the best answer, because we haven't reduced radicals much this semester, and there's no need to jump into that right now. Like I said, if I wanted to check, this is the version that I must use to check. It's the easiest version to use to check. And to check an answer to an antiderivative problem, you have to take its derivative and make sure that it equals to the original problem or something that can be transformed into the original problem. So I'm going to check by finding the derivative of 4/7 x to the 7/4 plus c. To find this derivative, I'll take the exponent of 7/4, multiply it by the coefficient of 4/7. I'll lower the exponent by 1, and by lowering it by 1, I'm going to minus 4/4. And then the derivative of c, because it's a constant without an x, is it has a derivative of 0. This multiplication right here, these are reciprocals, so they multiply out to be 1. My exponent turns into 3/4. So I get 1x to the 3/4 plus 0, which is just 1x to the 3/4. This is equivalent to this, which is equivalent to that. So because the derivative of my answer equals to what I integrated, I know my answer is correct. We don't have to go and check every single answer Otherwise, it's going to take 40 minutes longer to do this video than it needs to. But you can, if you have the time and you want to, if you get through the test quickly, check every integration problem and you can be guaranteed of a better score than if you don't check. All right, so problem 2, I don't know how to integrate this so well the way it's written. It also needs to be rewritten. And to rewrite this, I'm going to write it so the x isn't in the denominator. I have two choices on my rewrite of this. I could bring the x up to the numerator from the denominator. And when I do this, the exponent goes from a positive to a negative 3. Similarly, I could write the x to the right of the fraction 2/5 with the negative exponent. These are both correct rewrites. The second rewrite is probably better than the first rewrite in terms of it's easier to do the integration. And so now I'm going to integrate. When I integrate, I add 1 to the exponent and divide by the new exponent. So the original exponent of my x is negative 3. I'm going to add 1 to the new exponent. My new exponent's going to be negative 2. And then, to figure out what to do with the new exponent, what I'm supposed to do is divide by negative 2. Dividing by negative 2 can be written as dividing by negative 2 over 1 because negative 2 over 1 is the same. Dividing by negative 2 is the same as dividing by negative 2 over 1 because negative 2 over 1 equals to 2. But I'm going to, instead of dividing by negative 2 over 1, multiply by 1 over negative 2. And 1 over negative 2 is the same thing as negative 1 over 2. So instead of adding 1 to the exponent and dividing by the new exponent of negative 2, I'm going to add 1 to the exponent and get an exponent of negative 2. I'm going to multiply by negative 1/2, which is the same as dividing by negative 2. Now in this case, my 2's cancel. They become 1's. Technically, I have negative 1 times 1 in the numerator, which is negative 1, and 1 times 5 in the denominator, which is positive 5, times x to the negative 2. When I integrate and there aren't numbers on top and bottom of the integral sign, I always have to put that plus c down. So I'll put that plus c down. This is an okay answer to problem 2. It's okay because it's correct. It's not the best answer. The original problem didn't have a negative exponent. My answer probably shouldn't have a negative exponent. And a better answer, I guess probably best answer, would have that x to the negative 2 tucked into the denominator with the 5, and the exponent could be then made positive. This would probably be the best answer to number 2. Again, I can check. This is a hard version to check. To check, I need to take a version of the answer that's easy to take the derivative of. So if I was checking, I'd probably use this, and I'd find its derivative. So I'm going to do the derivative of negative 1/5 x to the negative 2 plus c, and it needs to equal that or reduce to that. To do this derivative, I'm going to multiply the exponent negative 2 by the coefficient negative 1/5, and I'm going to lower the exponent by 1. Negative 2 minus 1 is going to be negative 3. Take the derivative of the c, because it doesn't have an x, it's a constant. The derivative of any constant is 0. And simplify this by multiplying these, and you get positive 2 over 5 x to the negative 3 plus 0, and I don't need to write the plus 0. That's that, or something that's that at least, and this can be made with a positive exponent by just taking the x and shoving it down to the denominator. And because my derivative of the answer is the integrand of the original problem, I know my answer is right. I think this will be the last one I check. If I check every one, it's going to take a ridiculous amount of time. Unless I feel inspired to check another problem, I probably won't check too much. Problem 3 is yet a third one that needs to be rewritten and before I integrate. So I'm going to rewrite this as the integral of 6x squared over 2x plus 2x over 2x minus 4 over 2x dx. I'm going to reduce each fraction. The first fraction reduces. You divide the 6 by 2 and get a 3. Lower the exponent by 1 and get an x to the first. So the first division gives me a 3x. The second division, anything divided by itself is 1. The third division, you get minus 2 over x. I can integrate each one of those terms the way they're written, but it might help to give some more structure to this. So I'm going to write the 3x as 3x to the first. I'm going to write the 1 as 1x to the 0 power. And I'm going to write the minus 2x as minus 2x to the negative 1 power. And now I'm going to integrate each term. Technically, what I'm going to do is I'm going to find the integral of 3x to the first dx, and then I'm going to add to it the integral of 1x to the 0 dx, and then I'm going to subtract the integral of 2x to the negative 1 dx. Generally, I don't write this. Usually, I would just take integrate each one of these terms separately from there. The integral of 3x to the 1 dx is an easy one. I just add 1 to the exponent, divide by the new exponent. So I'm going to get 3x squared over 2. That can be written as 3/2 x squared, depending on what your preference is. I just instinctively wrote 3x squared over 2. In terms of if I was checking, it'd probably be easier to have the bottom version. To integrate 1x to the 0, I add 1 to the exponent. 0 plus 1 is 1, divide by the new exponent. And for that piece, the 1 over 1 is equal to 1. X to the first power can be written as just x. I'd probably write that piece as just x. Bring down the minus sign that's in front of the third term. When you have an x to the negative 1 for the integral, you get a natural log of that x to the negative 1 without the exponent inside an absolute value. The integral of any number times x to the negative 1 power is that number times the natural log of that value of x. And I need to tack on the plus c. So this would be a completely okay answer. Probably not written so nice because of that middle term. And this is a better version of that answer, written a little bit better. All right, so that's the first 3 problems. Check the first 2, didn't check the first 3. The next problems are a little bit different, and we'll just kind of keep going. The next couple are substitution problems. And so for number 4, when there's a parentheses with an exponent, you generally let the u be the contents of that parentheses. So I'm going to let u equal 3x squared plus 4x minus 2. And what that would make happen is you'd get the integral of 6x plus 4 times u to the 5th dx as your rewrite. And that's not really that great. I couldn't integrate that. So I'm going to take the derivative, and on this side we'll get a du dx, and on the right side I get a 6x plus 4. So the next change I'm going to make, I'm going to change a 6x plus 4 to a du dx, and when I do that I really don't need the parentheses anymore. And then we always took the time to cancel out the dx's. And now it's easy to integrate. Let me just write what I have here. I really have u to the 5th du. Now I'm going to add 1 to the exponent and divide by the new exponent. Tack on my plus c. And then get to an answer. In my answer, I'm just going to take the u and change it back to what it's equal to. And that divided by 6, you can make them multiply by 1/6 if you care to. So for my answer, I'm going to write 3x squared plus 4x minus 2 to the 6th over 6. That fraction can't reduce, plus c. The alternative you could do is you could write 1/6 times 3x squared plus 4x minus 2 to the 6th plus c. They're equivalently correct. And at this point, it's just a matter of preference, or what I'm going to do to the problem. If I'm doing more to the problem, like if I had to take the derivative of this version might be a little bit easier for me to apply the chain rule. But I'm not going to check this. But to check this, you'd have to take the derivative of. Let me just check it real quick. So if I wanted to check, the derivative of this should be that. To do the derivative of this, I take the exponent 6, multiply it by the coefficient 1/6, leave myself some room, lower that exponent by 1, where I left the room, I take the derivative of each term in the parentheses. The derivative of 3x squared is 6x. The derivative of 4x is 4. The derivative of minus 2 is 0. The derivative of plus c is 0. The 6 times the 1/6 cancels out to be a 1. So this version was easy to take a derivative of. And you're left with 6x plus 4 times 3x squared plus 4x minus 2 to the 5th, which is exactly the initial the stuff that was in my integral, between my integral sign and the dx in the original problem, so I know my answer is right. So each of the first 6 problems, if you take the time to take the derivative of your answer, you can make sure your answer is correct. 5 is another u substitution. When we have the e problems, we generally let the u be the exponent of the e, and that's what I'm going to do here. And then if I do my rewriting in stages, I think it's easier to follow, but you can do all your rewriting in one step. So I made my exponent into a u, and now I'm going to take the derivative of this. So the left side's going to be du dx, and the derivative of the right side is 6x squared. So for my 6x squared, I'm going to put a du dx in. And then I'm going to cancel the dx's, and I get the integral of e to the u du. And e is lovely when it just has a single exponent without, when it's just e to the x or e to the u, because it is its own integral. So the integral of e to the u is e to the u. And for my answer, I just need to change the u back to the 2x cubed. To check this, it's super easy. The derivative of any e is the e function times the derivative of its exponent. The derivative of 2x cubed is 6x squared. The derivative of plus c is 0. So the derivative of my answer is what's between the integral sign and the dx, so I know my answer is correct. Alright, for number 6, I'm going to let u equal the contents of the parentheses, so 3x squared plus 5. Then I can rewrite the original problem as 6x times u to the 4th dx. And then I'm going to do du dx. du dx equals to 6x. So now I can rewrite this as du dx times u to the 4th dx. Cancel my dx's, so I get the integral of u to the 4th du. Add 1 to the exponent, divide by the new exponent, put on my plus c, and to get to an answer, I'm going to change the u back to what it's equal to. So I'm going to write 3x squared plus 5 in place of the u. Need a parentheses now because the u changed into a binomial, to the 5th power over 5 plus c. And then again, you could write 1/5 as opposed to divide it by 5. Alright, I'm not checking that one, but I could. 7, 8, 9 are u substitutions where you're going to have to multiply before you can really do the u substitution. On 7, I'm going to need to write this problem with a negative exponent because it just makes it easier to do everything. So I have a parentheses with an exponent, and generally you let u be the contents of that parentheses. So I'm going to let u be x minus 2. And that allows me to rewrite the problem as 5 times u to the negative 3 dx. I'm going to take the derivative here and get, with respect to x, and get du dx. The derivative of x is 1, the derivative of minus 2 is 0. I'm trying to get rid of a 5 and I have a 1, and in order to change that 5, in order to get rid of that 5, I need to change the 1 into a 5 by multiplying by 5. That's going to give me 5 du dx equals to the 5 that I'm trying to get rid of. So the next few problems, we're going to have to multiply after we find the du dx to get the proper switching. So for this 5, I'm going to replace it with 5 du dx. I'm going to leave on the u to the negative 3 dx. I'm going to cancel the dx's, and I'm going to move the u over. So I'm going to get 5u to the negative 3 du. Now I add 1 to the exponent, divide by the new exponent, and when I do that, adding 1 to the exponent, divide by the new exponent, I don't write the integral sign anymore. I'll leave my plus c. I definitely want the u down in the denominator for my answer, and the negative looks odd. I'm going to do two things at once. I'm going to move the negative up to the numerator, and I'm going to move the u down to the denominator to get the negative signs in places where they need to be. So I'm going to write negative 5 over 2u squared plus c. That's my answer, other than the u needs to be changed to an x minus 2. So for problem 7, the best answer, or a best answer, would be negative 5 over 2 times x minus 2 squared plus c. That would be a real nuisance to check by taking its derivative, so I'm not even going to go there. But I'm going to glance at my work real quick to make sure I don't think I have a mistake. Because when I find a mistake, I redo the whole video, and that's not really a pleasant thing to do. Boom, boom, move x minus 2. Derivative is 1, so we need a 5. 5u to the negative 3, 5. Yeah, it looks good. All right. 8 has multiple things, and doesn't have the integral sign. 8 has multiple things other than it's missing the integral sign that makes it hard. For number 8, I need to get this problem written with a fraction exponent, and the denominator, the x cubed plus 4 under the radical, because it's a cube root, I'm going to turn it to a 1/3 power. Still not ready to integrate that. I'm going to get that parentheses up to the numerator so I won't have a fraction anymore. And now I can do the u part of this. So I'm going to let u equal x cubed plus 4. That allows me to rewrite this problem as 6x squared u to the negative 1/3 dx. I'm going to take the derivative of this. I'm going to get du dx equals to 3x squared, and the derivative of 4 is 0. I need a 6x squared, so I'm going to multiply both sides here by 2. And it's going to give me 2 du dx equals 6x squared. So for the 6x squared, I'm going to replace it with a 2 du dx. I'm going to cancel the dx's and write the du in a nice place. And now I'm going to add 1 to the exponent, and instead of 1 as a 1, I'm going to do it as 3/3. That's going to make the new exponent 2/3, because negative 1/3 plus 3/3 is 2/3. And instead of dividing by 2/3, I'm going to multiply by 3/2 to do my integrating. So to finish up the integrating, I add 1 to the new exponent. Instead of dividing by 2/3, I multiply by 3/2. That makes the 2's cancel. That gives me a 3 u to the 2/3, and I'm going to put it back in its radical notation. The radical notation would be 3 times the cube root of u squared plus c. And then to finish up the problem, I just need to change the u back to the x cubed plus 4. And I'm going to need to put it in a parentheses because it's a binomial and it has an exponent. So the best answer I can get for this problem is 3 times the cube root of x cubed plus 4 quantity squared, and then outside the radical a plus c. Let me just glance at this real quickly. So that looks okay. 1/3 power, negative 1/3 power, to multiply by 2, add 1, multiply by 3. Looks right. And checking it in my head without doing the derivative, it would be a pretty big nuisance to take this derivative to show that it equals to that. It's doable, but it's probably more than I'd care to do. Wow, lots of integrals. Problem 9, I need to think of the denominator as having a parentheses with an exponent of 1, so I can get this fraction rewritten in a form that I can do an integral with. So I'm going to rewrite this problem, and generally I don't like fractions when I have to integrate. Generally we take the entire denominator, we move it up to the numerator before we integrate, and that's what's going to happen here. So it took me kind of 2 steps to get rid of the fraction. And like always, when there's a parentheses with an exponent, we generally let the u be the inside of that parentheses. So that will allow me to make this 6x squared u to the negative 1 dx. Find the derivative of u, du with respect to x. That's going to be du dx is 6x squared. And now it's just a straight substitution. I'm going to put in for 6x squared, I'm going to put du dx. I have u to the negative 1 dx. I'm going to cancel the dx's, and I'm going to get the integral of u to the negative 1 du. And when you have a negative 1 for your exponent, you get the natural log. Technically, you need an absolute value. So the integral is the natural log of the absolute value of u. And for my answer, I'm going to change that u back to the 2x cubed plus 5 that it's equal to. And because I have an absolute value sign, I don't really need a parentheses. The absolute value sign itself is working like a parentheses. Alright. Yeah, it looks perfect. Alright, my number 10 was messed up on the original video, so I'm just kind of cutting it and putting it incorrectly. In order to integrate for number 10, I have to make the denominator have a parentheses with an exponent so that I can get rid of the fraction. And the denominator didn't start with a parentheses, so the exponent that my parentheses needs to get that I'm inserting is an exponent of 1. Now I can get rid of the fraction by moving the entire denominator up to the numerator. And the numerator that didn't initially need to be put in a parentheses now needs to go in a parentheses because it's multiplied by the denominator, and the numerator is a binomial, and the parentheses are appropriate here. You probably could get the right answer without putting the parentheses in, doing some math that isn't maybe perfect, but that's probably the best way to rewrite number 10 to get going. And now you let u be the contents of the parentheses. So I'm going to let u be x cubed plus 4x squared plus 1. And just to save a second, I'm going to do the derivative of this. I'm going to get du dx equals to the derivative of x cubed, which is 3x squared, the derivative of 4x squared, which is 8x, and the derivative of 1 is 0. I'm going to want to replace a 9x squared plus 24x with my du dx. I have a 3x squared plus 8x. If I multiply everything by 3, I get 3 du dx equals 9x squared plus 24x. I'm going to do two substitutions at once rather than doing them separately like I have been doing. For this piece right here, I'm going to put in a 3 du dx. For this piece right here, I'm going to put a u. I'm going to leave the exponent of -1, and I'm going to leave the dx. I'm now going to cancel my dx's, and I get 3 u to the -1 du. I probably should have a string of equal signs that I haven't taken the time to put in, but they're probably correct to have in. Now I'm going to integrate, and when you have a -1 exponent, you get a natural log in your integration. The integral of 3u to the -1 is 3 times the natural log of the absolute value of u plus c. Now I just need to change my u back to what it's equal to. I get 3 times the natural log of the absolute value of x cubed plus 4x squared plus 1. Close my absolute values, put the plus c. I didn't take the time to put the x cubed plus 4x squared plus 1 in a parentheses because it really wasn't necessary. The absolute values are working like a parentheses. So whether your answer does or doesn't have the x cubed plus 4x squared plus 1 in a parentheses, as long as you have the absolute values, the parentheses aren't necessary. So that was a really 3-minute and 30-second quick fix for problem 10. Hopefully it was followable. If not, let me know and I'll refix it again. So I'm going to cut this back into the video, so there's going to be probably some hiccups between problems 9, 10 going into 11. All right, last integration for a second. For number 11, it doesn't need to be rewritten, other than I need to do a u substitution. I'm going to let u be x cubed minus 2. That will allow me to write the problem as the integral of 12x squared times u to the 5th dx. I'm going to take the derivative, and I'll get du dx is 3x squared. But I need to get rid of a 12x squared, so I'm going to multiply both sides by 4. And that's going to give me a 4 du dx equals 12x squared. So for the 12x squared, I'm going to change it to a 4 du dx. Leave this stuff intact. Cancel out the dx's. Write it in a nice order. Add 1 to the exponent, divide by the new exponent, so I'm going to get 4u to the 6th over 6 plus c. I think I can get straight into a good answer. I'm going to reduce the 4/6 to 2/3, and I'm going to change the u to x cubed minus 2. My work up top was a little jumbled, so it was hard for me to figure out what I put the u. So I'm going to go 2 times x cubed minus 2 to the 6th over 3 plus c. You can make this if you really care to. If I was checking this using the chain rule, I could probably write this as 2/3 times x cubed minus 2 to the 6th plus 2/3 plus c. And then, since I have a minute, I'm going to check this. To check this, I do use the chain rule. So my checking, I take the 6, multiply it by the 2/3, leave myself some room, take the exponent, lower it by 1 to 5. The c has a derivative of 0. In this parentheses, I take the derivative of x cubed, which is 3x squared, the derivative of minus 2, which is 0. Outside my radical, the 6 divided by 3 is a 2. That's going to give me 2 times 2 is 4. So I'm going to have 4 times 3x squared times x cubed minus 2 to the 5th. I multiply the 4 times the 3x squared and get a 12x squared times x cubed minus 2 to the 5th. And what that needs to equal is that. Can't see them both at the same screen at the same time, but that's what my derivative had to equal. It had to be equal to exactly what it's equal to, so my answer is spot on. Okay. All right, so 12 is the trapezoidal rule, and the trapezoidal rule wants me to make a picture, and on that picture draw trapezoids and do some area shading. So for problem 12 part A, I'm going to graph the function x cubed plus 4 between x equal to 1 and x equal to 5, and I'm going to label the endpoints. So my first step of problem 12, and we did a lot of these on just a lot of the parts just on the graph itself. So as I start to do problem 12, on my x-axis I know I have to have the number 1 and the number 5. And in a second, I'll figure out what other numbers I need to have. I'm going to graph the function x squared plus 3 and find the y-coordinates for 1 and 5. And when I do my window for this problem, I'm only going to do x equal to 1 to x equal to 5. Oh, and my y's are going to have to be way higher. When I plug 5 in for x, I get 5 squared is 25 plus 3 is 28. My y max has to be at least 28. I'll do 30. And now I'm going to figure out each of the y's. So I'm going to go second calc value 1. And at 1, I get the 0.14. And I don't have to be that accurate with my graph here. So there's my 0.14. And for 5, I type in the number 5, I get 28. And so this is kind of the graph. I know I'm going to draw this down here and this down here. This is the beginnings of my work. So that's kind of part A. I've created the graph of the function that's going to help me. Now I need to divide the x-axis into intervals, and I'm going to go last x minus first x divided by the number of intervals. And this problem I'm told to do 4 intervals. And that's going to tell me how far to make the marks apart on my axis. So I'm going to take the last x minus the first x, numbers I put on the x-axis, divided by the number of intervals. That's going to be 4 divided by 4. That means every one, I have to add 1 to this number to get where my next trapezoid is going to eventually be drawn. So first one, I'm going to go 1 plus 1 is 2, and then 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5. For each of the numbers I just put on the x-axis, by adding 1 to the starting number until I got to the ending number, I need to find y's as well. I'm already in y mode, so I'm going to go second calc value, type in 2. This is the 0.27. And I'm going to do 3 and 4. This is the 0.312. And the last point is the 0.419. The y's are going to be the important parts of these. I already know what the x's are. So I've subdivided the x-axis, so that's part B. And then for part C, evaluate each function at the value that you put on the x-axis. So this is all A, B, and C together. I used my calculator to create a graph. I figured out how far I needed to make the numbers on the x-axis apart, wrote the numbers on the x-axis, and then I used my calculator to get a y value of 7, a y value of 12, a y value of 19. I already had a y value of 28 and a y value of 4. Now I'm going to draw my trapezoids. So the first trapezoid is going to be, I need something else here. My first trapezoid is going to go from there to there to there. My second trapezoid connects these points and goes down. Third trapezoid connects those points, goes down. My fourth trapezoid does that and goes down. So those are the trapezoids that are implied by my picture. And so I'm going to call this one trapezoid 1, this one trapezoid 2, this one trapezoid 3, and this one trapezoid 4. And so I'm done with part D. So A through D all show up on this graph. I don't need to show any separate worker for each really. But for E, I need to do that off to the side. So E is find the area of each trapezoid, and they're really easy to do. So for my area of trapezoid 1, it's going to equal to the height, and each of the heights is the distance between the numbers on the x-axis, which is 1, times the y-coordinate of that, the left edge, plus the y-coordinate of the right edge, divided by 2. So trapezoid 1 has an area of 11 over 2. Now I'm going to move to trapezoid 2. The height is 1. I add the y-coordinate of the left edge plus the y-coordinate of the right edge and divide by 2. For trapezoid 3, the distance between 3 and 4 is the height, which is 1. I multiply by the sum of the y-coordinate of the left edge plus the y-coordinate of the right edge, divided by 2. 12 and 19 is 31, and then over 2. And then lastly, the area of trapezoid 4 is the height, which is 1, times the y-coordinates of the edges, which are 19 and 28, over 2. 28, 30. This is 47 over 2. And this is the answer to part E. Find the area of each individual trapezoid. So this is 12E. And part F is to add the individual areas together to get an estimate of the area under the curve. And for 12F, I'm going to do that all in my calculator and just write a number down. So I'm going to go to the main screen of my calculator and add those numbers. So second quit, I'm going to go 11 divided by 2 plus 19 divided by 2 plus 31 divided by 2 plus 47 divided by 2. And I get 79.5. I'm going to math, enter that, and write 159 over 2. What I could have done is just added 11 plus 19 plus 31 plus 47, and know that I made a mistake somewhere, huh? Let me redo this adding. Could do 11 divided by 2 plus 19 divided by 2 plus 31 divided by 2 plus 47 divided by 2. Really? I got 54. So I thought I made a mistake here. I think this should be 54. The nicer way to do this would have been just to add the 11, the 19, the 31, and the 47. 11 plus 19 plus 31 plus 47. And then do divided by 2. And there's the 54. So the 54 is the right estimate. That's saved myself on 12F. Now I'll move on to 12G and do the exact area. And we've done a ton of those, so I'll do that in a second. So the exact area, and my area has to be a little bit higher than the exact area, because you notice the trapezoids that I drew go slightly above the graph that I can find the exact area for on my calculator. So on my calculator, I'm going to integrate from 1 to 5 the function that we have, and the function is x squared plus 3. So that's what I'm going to do on my calculator, because the function that we started with was the x squared plus 3. I'm going to integrate it from 1 to 5 to get the exact area, and I'm going to live with a 2 decimal answer, and it should be slightly smaller than that. If I get a number bigger than 54, I'm worried, because my trapezoids are slightly bigger. The area of the trapezoids, there's a little gap above the trapezoid compared to the graph. So there's my y equals, there's my graph. Second calc, go down to option 7, integrate from 1 to 5, and hopefully it's like 53 point something. That's beautiful. So 53.33 rounded to 2 decimals. And there's no work you have to show for part G. So that's everything for number 12. So parts A through D, where it asks me to create a graph over the interval from 1 to 5, subdivide the x-axis by going 5 minus 1 over 4, making marks on the x-axis, getting a y for every number that you have on the x-axis, draw the trapezoids. All that shows up on the graph. And then the areas are really easy. The heights, which come first in the numerator, are just how far each of the numbers on the x-axis are apart. You add the y's of the left end point and the right end point for the trapezoid and divide by 2. So A through D are just all in the pictures. E is just finding the area of each one of these trapezoids. F is just adding each of those areas together. And G you can only do we could actually do it by hand, but I asked you to use your calculator to do it. All right. So for 13 through 16, I'm asked to use my calculator and then do it by hand. So for 13A, I'm going to use my calculator, and you can't really show anything here other than the answer that your calculator gives me. So I'm going to enter the function 4 times the square root of x. And then my window has to go from x equal to 1 to x equal to 9. And I'm going to make my y's back to normal. I don't have to see the picture here perfectly. If it shoots off the screen, I can live with it. And now I'm going to go second calc, number 7, lower limit 1, upper limit 9. I'm going to round that to 2 decimals. So calculator, we'll just say C calculator. You don't have to write that on a test, but I tell you to use your calculator. There's nothing you can really show me. For part B, I want to get the best I can, the exact area. I have to rewrite this problem. And after I rewrite the problem, I can integrate. And when I integrate, I have to add 1 to the exponent. And the way I'm adding 1 is going to be 2 halves. So my new exponent is going to be 3 halves. And instead of dividing by 3 halves, I'm going to multiply by 2/3. So times 2/3. I need to evaluate that at 1 and 9. So I'm going to make this 8/3. And then instead of x to the 3 halves power, I'm going to make it the second root of x cubed. Evaluate it from 1 to 9. That's a square root. And now I'm going to write 8/3 times the square root of 9 cubed minus 8/3 times the square root of 1 cubed. And eventually I always get to my calculator. And right here I'm going to get to my calculator. These answers are going to come out to decimals. I think I should be able to make them into fractions. So first one, back to my main screen. I do 8 divided by 3 times the square root of 9 cubed. Well, it comes out to 72, just lovely. And then second piece, 8 divided by 3 times the second square root of 1 cubed, and math, enter that. That comes out to 8 over 3. And then I'm just going to go 72 minus 8 divided by 3. Hopefully I get something close to 69.33. It's exactly, that's what I wanted to get. But my answer needs to be not a decimal, it needs to be a fraction when you're doing it by hand. I'm going to write 208 over 3 for my answer. So for 13b, you need to show the work, and you need to write your answer as a fraction as opposed to a decimal. All right. 14a, use my calculator, so I'm going to graph this horrible function. So y equals clear 3x squared minus 5 parentheses x up arrow 3 minus 5x plus 1 up arrow 5. Believe that's the function. 3x looks good. Set my window, go between -2 and +1. Graph it. I don't have to see the graph perfectly. I don't need to really tweak my window in this section, this group of problems. I can still go second calc, option 7, lower limit -2, upper limit 1. And for 14a, I'm going to get I get the answer 0. That's shocking to me, but kind of nice. So in this group of problems, we're letting the area beneath the x-axis be negative and the area above the x-axis be positive. It's not to the point until I give you a problem without an integral sign and ask you to specifically find the area between the x-axis and the curve by when I get a little bit later, the instructions will tell me to find the x-intercepts, and then I'll know that I want the area beneath the x-axis to be positive. But for this group of problems where it just says use your calculator and doesn't make any comment about area, it's sufficient just to use your calculator, and we'll try to match up our calculus without having to worry about x-intercepts in positive and negative areas. So to do this by hand, my 14b, I have to do u substitution. I'm going to let u be x cubed minus 5x plus 1. Then du dx is going to be 3x squared minus 5. And I'm going to do 2 substitutions at once. I'm going to let this be du dx, and this be the u. Guess I didn't need a parentheses there. I'm going to cancel the dx's, write it in a nice order, and integrate by adding 1 to the exponent and dividing by the new exponent. Change my u back to the nasty thing that it is. I have to evaluate that at -2 and at +1, and I hope like heck I pull out a 0. And that's going to take a lot of room, so I'm going to do all this work plugging 1 in and plugging -2 in on a separate sheet of paper. So when I plug 1 in, I have to, so the original function that I'm dealing with there is x cubed minus 5x plus 1 to the 6th over 6. I'm supposed to evaluate it at 1 and at -2. To do it at 1, I'm going to do 1 cubed minus 5 times 1 plus 1 to the 6th power over 6, and then minus, I'll do the -2. -2 cubed minus 5 times -2 plus 1 to the 6th over 6. And you have to show all this work to get full credit. Well, you have to show that what you're doing on your calculator. You don't have to do that by hand. So now I'm going to do this. 1 cubed, because 1 is positive, doesn't really need to be in a parentheses. error syntax. Well, apparently I forgot a parenthesis. So I should have done this. I should have parentheses 1 exponent 3 minus 5 parentheses 1 plus 1 up arrow 6 and then divided by 6. I get 121.5. I'm going to math enter that and get 243 over 2. Carry down my minus sign and do the next one. So parentheses negative 2 up arrow 3. I needed an extra parentheses and then parentheses negative 2 up arrow 3 minus 5 parentheses negative 2 plus 1 up arrow 6 divided by 6. I get the exact same number of 243 over 2. So my answer to part 14b is 0, which is beautiful. Alright, I'm going to split this video into 2 parts because my video is getting ready to end again, and so I'm going to pick up with number 15 on part 2. So just finished 14. We used my calculator to get the definite integral, got an answer of 0, did the integration by hand using U substitution. After I got the problem integrated and the letters from U back to X, I did my antiderivatives and plugged my numbers in and got the same answer that my calculator gave me.